Welcome to Study Loop.
Okay, we want to know the mass in grams of 42.20 moles of sodium iodide. And so what we need is some factor which contains both grams and moles. And so we need something that tells us grams per mole or mole per gram, right? And as it turns out, what we're really after is the so-called molecular weight, or MW. And the molecular weight tells us for any molecule, such as sodium iodide, the number of grams in a mole of that molecule. And as it turns out, for sodium iodide, the value is 149.89 grams per mole of sodium iodide, right? So this is exactly the number that we were after, because since it is a number which contains with units both grams and moles of sodium iodide, we can multiply it by this number, which contains only moles. And what we'll find is that our final answer, after we multiply the two numbers together and cancel any units that may be primed for canceling, we will get an answer which contains only grams. So let's draw this out and see what I mean. What I'm saying is that if we take 42.20 moles of sodium iodide and multiply it by the factor 149.89 grams per 1 mole sodium iodide, our final answer numerically will be, let me put this into my calculator, 42.20 times 149.89 equals, and I'm going to put this in scientific notation, 6.325. I'm going to round this up to 4 times 10 to the third. What are my units? Okay, well, we had moles of sodium iodide, and well, it's not in a fraction, but anytime we have a number that's not a fraction, it's okay to just turn it into a fraction by putting it over the number 1. It doesn't change anything mathematically, but it makes it easier to think about this being a fraction with the units of sodium iodide in the numerator. Okay, and then if we look at our next factor, we have 1 mole sodium iodide in the denominator. And whenever we see units in the numerator multiplied by those same units in the denominator, we can cancel them, right? So we won't have moles of sodium iodide in our final answer. So what units remain? No units here, no units here, no units here. All that's left is grams. So our final answer will be in units of grams, which is great because that's exactly what we were looking for. Now our final task is to reduce this to the correct number of sig figs. If you note, we had 4 sig figs in our initial answer. None of our factors had fewer than 4 significant figures of certainty, which means that we need to round our final answer to 4 significant figures, which in this case would be just lopping off the 4 because it won't round up, it will round down. So our final answer should be 6.325 times 10 to the third grams, or if you're more comfortable, 6,325 grams. Same answer.